Imagine the vastness of space, the infinite expanse that stretches beyond our comprehension, filled with wonders and mysteries that have captivated humanity for centuries. Billions of galaxies, each with billions of stars. These celestial bodies form the grand tapestry of the universe, a cosmic dance that has been ongoing for billions of years. And around many of those stars, planets. These planets, known as exoplanets, come in all shapes and sizes, some potentially harboring the conditions necessary for life. Could we be alone in this vast cosmic ocean? This question has haunted scientists, philosophers, and dreamers alike. The search for extraterrestrial life is not just a scientific endeavor, but a quest to understand our place in the universe. Or is there life out there, waiting to be discovered? The search for extraterrestrial intelligence, or SETI, has been at the forefront of this quest, scanning the skies for signals that could indicate the presence of other civilizations. In 2016, astronomers detected a strange signal from the direction of Proxima Centauri, the closest star to our Sun. This discovery was a significant milestone in our search for extraterrestrial life. This signal, dubbed BLC-1, sparked excitement and speculation. Scientists around the world began to analyze the data, hoping to uncover the origins of this mysterious signal. Could this be a message from an alien civilization? The possibility was tantalizing. If confirmed, it would be one of the most profound discoveries in human history. The signal originated from the Proxima Centauri system, just 4.2 light-years away. This proximity makes it an ideal candidate for further study and exploration. This makes it our closest stellar neighbor. Proxima Centauri is a red dwarf star, much smaller and cooler than our Sun, but it holds a special place in our quest for knowledge. The prospect of finding even the faintest hint of life so close to home is incredibly exciting. It fuels our imagination and drives our scientific endeavors. The discovery of BLC-1 ignited our collective imagination. It reminded us that the universe is vast and full of possibilities, and that we are just beginning to scratch the surface of its mysteries. It served as a powerful reminder that we might not be alone in the universe. The search for extraterrestrial life is a journey that transcends borders and unites us in our quest for knowledge. It fueled our desire to explore further, to listen more closely, and to unravel the mysteries of the cosmos. As we continue to search the skies, we remain hopeful that one day, we will find the answers we seek. How do we even begin to listen for whispers across the vastness of space? The answer lies in incredible feats of engineering and technology: radio telescopes. Radio telescopes are essentially giant antennas pointed at the sky. They capture radio waves, a type of light invisible to our eyes. These waves travel through space, carrying information about distant objects. The Parkes Observatory in Australia, one of the telescopes that detected BLC-1, boasts a dish, 64 meters in diameter. That's larger than a basketball court. This massive size allows it to gather faint radio waves from incredibly distant sources. But size is only part of the story. Sophisticated computer algorithms are used to analyze the collected data. These algorithms can sift through the cosmic noise, searching for patterns and anomalies that might indicate an artificial signal. BLC-1 wasn't just any random blip on a screen. It was a signal that captured the attention of scientists around the world, sparking curiosity and excitement. This wasn't the first time a mysterious signal had been detected, but BLC-1 had something special about it. Several characteristics made it stand out from the usual cosmic static. Unlike the background noise that fills the universe, BLC-1 had distinct features that set it apart. These unique features are what led scientists to consider the possibility of an artificial origin. The idea that this signal could be from an intelligent source was both thrilling and daunting. First, the signal was incredibly narrow in bandwidth. This is significant because natural sources like stars or galaxies typically emit radio waves across a broad spectrum. Natural sources tend to produce radio waves across a wide range of frequencies. The fact that BLC-1 was so concentrated suggested it was not a natural phenomenon. BLC-1, however, was concentrated within a very specific frequency band, suggesting a focused transmission. This kind of precision is typically associated with technology, not nature. Second, the signal drifted in frequency in a way that hinted at a source in motion. This drift is known as the Doppler effect, which occurs when the source of a signal is moving relative to the observer. This is consistent with a signal originating from a planet orbiting a star. As the planet moves in its orbit, the frequency of the signal changes slightly, just like the sound of a passing car changes pitch as it moves past you. As the planet moves, its motion relative to Earth would cause the signal's frequency to shift slightly. This subtle change in frequency was a key clue that the signal might be coming from a distant world. Finally, and perhaps most intriguingly, the signal appeared to repeat. Repetition in a signal can be a sign of an intentional transmission, as opposed to random noise. While the repetition wasn't perfectly periodic, it was enough to raise eyebrows. The idea that this could be a message, a beacon, or some form of communication was tantalizing. Could this be an attempt at communication, a beacon from a distant world? The implications of such a discovery are profound, potentially changing our understanding of our place in the universe. The fact that BLC-1 originated from the direction of Proxima Centauri added another layer of intrigue. Proxima Centauri, the closest known star to the Sun, is a red dwarf located just over 4 light-years away from us. This proximity makes it a prime candidate for astronomical studies and the search for extraterrestrial life. The signal's origin from this star system has sparked a flurry of excitement and curiosity among scientists and space enthusiasts alike. This star system is home to Proxima B, a planet roughly the size of Earth orbiting within Proxima Centauri's habitable zone. Proxima B was discovered in 2016 and has since been a focal point for researchers due to its potential to support life. The planet's size and location make it an intriguing subject for further exploration and study. The habitable zone is the region around a star where temperatures are just right for liquid water to exist on a planet's surface. This zone is often referred to as the Goldilocks zone, where conditions are neither too hot nor too cold, but just right for life as we know it. The presence of liquid water is a key factor in the search for life beyond Earth. Water is essential for life as we know it. It acts as a solvent, a medium for chemical reactions, and a means of transporting nutrients and waste. The discovery of water on another planet would be a monumental step in our quest to find extraterrestrial life. So, finding a planet in the habitable zone is a big deal. It raises the possibility that life could exist elsewhere in the universe. The discovery of Proxima B has opened up new avenues for research and has fueled the imagination of scientists and the public alike. Proxima B is tidally locked to its star, meaning one side always faces the star while the other remains in perpetual darkness. This unique characteristic results in a stark contrast between the planet's day side and night side, creating a challenging environment for life to thrive. This creates extreme temperature differences across the planet's surface. The day side could be scorching hot, while the night side could be freezing cold. These harsh conditions pose significant challenges for the potential development and sustainability of life. However, even with this tidal locking, Proxima B could still potentially harbor life. Scientists speculate that life could exist in the twilight zone, the region between the light and dark sides, where temperatures might be more moderate and stable. The presence of an atmosphere could help distribute heat more evenly. An atmosphere could act as a blanket, trapping heat and redistributing it across the planet's surface, potentially creating more habitable conditions. And if there are oceans, life could thrive in the twilight zone between the light and dark sides. Oceans could provide a stable environment, with liquid water and the necessary nutrients to support life. The potential for life on Proxima B, despite its extreme conditions, continues to captivate scientists and fuel ongoing research. The news of BLC-1 spread like wildfire through the global scientific community. Excitement was palpable, but so was a healthy dose of skepticism. Extraordinary claims require extraordinary evidence, and scientists were eager to rule out all other possibilities. Researchers around the world turned their telescopes towards Proxima Centauri, hoping to confirm the signal and gather more data. Teams scrutinized the original data, looking for any possible errors or inconsistencies. The search for extraterrestrial intelligence, or SETI, is a rigorous endeavor. False positives are not uncommon. Radio interference from Earth-based sources or natural astronomical phenomena can sometimes mimic the signatures of artificial signals. While the possibility of BLC-1 being an alien transmission was tantalizing, scientists remained cautiously optimistic. More observations and analysis were needed to determine the true nature of the signal.